Hello everybody. Today I will be solving exercise 14 on chapter 13 of our physics textbook. Um, so from looking at this, we can see that we're given the diameter of planet Z, and we know that the free fall acceleration of planet Z is 8 meters per second squared. So part A asks for the mass of planet Z. Um, looking at our textbook, we find that we have an equation here that has most of what is given here. So far we're given the diameter, and from that we can find the radius, which is just half of that, which is 5,000 kilometers. We know the universal constant, big G, which is Newton's number, and we know the free fall acceleration on the surface, which is just little g, and what we're trying to find is the mass of the planet. So after some rearranging, we get this little g times the radius squared over big G. And after plugging in, we can get 3 multiplied by 10 to the 24th kilograms, which sounds about right. It's a very big number for a planet. And the second part asks us for the free fall acceleration 10,000 kilometers above planet Z's North Pole. In order to find the free fall acceleration of a planet at a certain height, we can use this equation, which is on page 342 of our physics textbook. And as you can see here, we can find the value g at a certain height, and we're given and in order to find this, we need the universal constant g, the mass of the planet, which we got from part A, the radius, which is given to us, and the height, which is also given to us. It says to find it 10,000 kilometers above planet Z's North Pole. And when you think about this number, 100 kilometers, just think, what does it remind you of? I'll give you a second to just think about it. You can pause the video here. Alright, have you guessed it? Yeah. It's the exact same number as the diameter of planet Z, so that means that it's twice the radius. And in doing so, showed a little bit too much there. And in doing so, we can rewrite this equation as g times m over 3r squared, where the h turns into 2r, so then we add them together, and it becomes 3r squared down here. Oh, my bad. Give me a second. Alright, and we can isolate the 3 in 3r squared down here to just make it 1/9 times big G times the mass of the planet over the radius of the planet squared. But you might realize that this is what is the formula for the gravity on the surface. So this is given to us, and it's 8 meters per second squared. If we just plug that in instead of this, we can get 0.89 meters per second squared, which is just 8 times the 9th. Thank you.